to another video on periodic table. Now, what is periodic table? It is a table that shows the arrangement of elements. It shows the arrangement of elements in line with their properties. Most especially the chemical properties. Number 2 is that the periodic table is arranged in 2 dimensions. It is arranged in 2 dimensions. Now, what are we talking about? What is the 2 dimensions that we are talking about? It is arranged in rows and column. The periodic table is arranged. The elements on the periodic table are arranged in rows and columns. Now, what is the rows? Now, let's use the first 20 elements as an example. We have the hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus is P, phosphorus, sulfur, chlorine, argon, potassium, calcium. Now, if you have this is row, this is column. Now, each row represents period and each column represents group. So that means if you're talking about these first 20 elements, we have this to be first column to be first group, second group, third group, fourth group, fifth group, sixth, seventh, and eighth group. But we have 1, 2, 3, 4. That's the fourth 4 rows, and that is 4 periods. But you should note that there are 18 groups. There are 18 groups on the periodic table. There are 18 groups on the periodic table, but out of these 18, we only have 8 major groups. And these are they. That is why when you want to name this, you name it as group 1A. You name the second one as group 2A. You name the third one to be group 3A. This one will be group 4A. This one will be group 5A. This one will be group 6A. This one will be group 7A. And this one is group 8A. Group 8A. So that is why we put AA there. Because if you don't put A there, we have the total number of groups to be 18 on the periodic table. But once there is A, then that shows that you are talking about the major groups, which are just what? 8 groups. Now, we have 18 groups in which I told you that 8 are the major ones, and we have the total number of 7 periods on the periodic tables. We have 7 periods, but we have the total of 18 groups. But out of the 18 groups, we have the 8 major groups in which I explained how. Now, according to Aufbau's principles, which gave the electronic configuration of each element on the periodic table, configuration of each element on the periodic table. Now we are talking about the elements on the periodic table as we have, let us firstly talk about the first 20 elements. Let's check. The first 20 elements we have, number one, let's talk about the elements. Number one, we have the first element on the periodic table to be hydrogen. And what is the symbol? The symbol of hydrogen is H. And let me talk about each state of this element. Hydrogen is known as it is gaseous in state. And what is the atomic number? The atomic number, and let us talk about the atomic mass. Now let's talk about these properties. It is gaseous, but the atomic number of hydrogen is 1, and the atomic mass of hydrogen is also 1. On the norms, it is 1.008, but approximately let us have it to be 1.0. The second one we look at is helium. Helium is, the symbol is He, and it is also gaseous. It has the atomic number to be 2. Atomic number means the number of each element on the periodic table, that is where they fall to on the periodic table. That is the atomic number. Now, and the mass number for helium is 4. Most elements on the periodic table, they have their atomic mass to be times 2 of the atomic number. So this one times 2 will be 4. Number 3, let's talk about the lithium. Lithium symbol is Li, and lithium is solid in state. It has the atomic number to be 3 and the atomic mass to be 7 for lithium. So that is all times 3. We have number 4 to be beryllium. Beryllium has the symbol to be Be, and it is solid in state as well. And at the same time, the atomic mass is 4. Then the atomic number is 4. Then the atomic mass is what? Is 9. We have number 5. We have the boron. Boron is B, and it is also solid state. The atomic number is 5, and the atomic mass is 11. We also have number 6 to be carbon. Carbon is, the symbol is C. It is also solid in state, and at the same time, the atomic number is 6, but the atomic mass is also 12. But carbon can undergo difference in the mass number. It can have difference in the mass number because it can undergo isotopy, because don't forget the process called isotopy. The atom with the same atomic number but different mass number. So it can also have the atomic mass to be 13. Sometimes it can have it to be 14. Now number 7. We have nitrogen. Nitrogen, the symbol is N, and nitrogen is gaseous in state. And at the same time, nitrogen has the atomic number to be 7, and the atomic mass will be 14 times 2 by 8. We have oxygen. Oxygen is O, is also gaseous in state. Atomic number to be 8, and the atomic mass to be 16. Oxygen as well can also have it to be 17 sometimes, and sometimes 18. Number 9. You have fluorine. Fluorine symbol is F, and it is gaseous in state. Number 9. And it has the atomic mass to be 18.99. So approximately, let us say 19. Number 10, we have neon. Neon is Ne, and it is also gaseous in state. It has the atomic number to be 10 and the atomic mass to be 20. Number 11, we have the sodium. Sodium is Na. It is solid in state. 11, and the atomic mass is 23. Number 12, we have magnesium. Magnesium is Mg. The capital, the first, whenever you have the symbol to be two letters, the first one will be capital letter and the second one will be small letter. We have Mg. It is also solid state, and at the same time we have 12 times 2 will be what? 24. We have 13. We have aluminium. Aluminium is Al, and at the same time it is solid in state. No 13, so times 2 plus 1, that will be 27. So this one is 27. We have number 14. Number 14 is silicon. And the silicon has the symbol to be Si, in which it is solid in state, and at the same time, don't forget it is 14. So times 2, we have it to be 28 as the atomic mass. Number 15. We have it to be phosphorus, and the symbol is P, in which it is solid in state, and at the same time you have 15. So times 2, we have 31 plus 1. So the atomic mass of phosphorus is 31. Number 16. We have the sulfur. Sulfur is S. It is solid in state, and at the same time you have 16. So times 2, that's 32. We have number 17. Number 17 is chlorine. Chlorine is Cl. It is gaseous in state, and at the same time we have it to be 17, in which chlorine has the atomic number to be 35.5 averagely. 35.5. Sometimes we can have chlorine to be 35, we can have it to be 36, we can even have it to be 37. Number 18, we have argon. Argon is Ar. It is gaseous in state. 18. So we have the atomic mass of argon to be 40. And at the same time, we have 19. 19 is potassium. Potassium is K. It is solid in state. 19. So we have the atomic mass of potassium to be 39.1. And the last one, 30. Number 20. We have to be calcium. And the calcium is Ca. We have to be solid. And at the same time, calcium, which is 20. And the atomic mass of calcium is 40.1. So this is the first 20 elements with the symbol, the state, atomic number, and the what? And the atomic mass. So now, let us go back to the electronic configuration according to Aufbau's principle. It gave us this principle in which we have 1s, 2s, 2p in terms of SPDF. Now for the SPDF, the F has the highest electron to be contained to be 2. The P has it to be 6. D has the highest electron to be 10. And F has the highest electron to be 14. That's the only thing it can contain. So let's follow this pattern of the Aufbau. We have 1s, 2s, 2p. We have 3s, 3p, 3d. We have 4s, 4p, 4d, 4f. We have 5s, 5p, 5d, 5f. Now you now draw the structure downward. We take it from the top downward. So let's take the arrow from top downward as well. So this is it. Now can you see? Now that shows if you want to start, you start with the first one there. That's 1s. The next one is 2s. So if you see this one, The next arrow is this. So you are going to start from the back. So we have 2p, we have 3s. The next one is 3p, we have 4s. Next one is 3d, 4p, 5s. Next one is 4d, 5p. So that is how it continues. So we have 4f, 5d. But don't forget that the highest electron that s can contain is 2. The highest electron that p can contain is 6. The highest electron that d can contain is 10. For f is what? Is 14. So let us look at some example of some elements. Now for the first element, let's look at the chlorine. Chlorine is atomic number 17. Now chlorine that is atomic number 17. Now chlorine will have the atomic electronic configuration to be, the first one, don't forget, is 1s. And s, the highest is 2. So next one is what? 2s. So the highest is also what? 2. Next one will be 2p. P, the highest is what? Is 6. Next one is what? 3s. The highest of s is 2. If you add this together, 2 plus 2 is 4 plus 6, that's 10 plus 2, that's what? That's 12. So we need 5 more. After 3s, the next one will be 3p. So 3p, the highest is 6. But what we need is just 5. So that is why, if you add them together, it will be 2 plus 2, that's 4 plus 6, that is 10 plus 2, that's 12 plus 5, that's 17. So this is the electronic configuration of what? Of chlorine. Now the next one, let's look at sodium. And don't forget that the electronic configuration of sodium, as I gave it to you, the atomic number of sodium, as I told you, is what? Is 11. So since the atomic number of sodium is 11, so let's go. The first one will be 1s, the highest is 2, 2s, the highest is 2, 2p, the highest is what? 6. You know, this one already make 10, so we need 1. So the next one will now be 3s, so just have it to be 1. Let's look at another example. We have the phosphorus, and phosphorus is 15. So let's look at that. That will be 1s, the highest is 2, 2s, the highest that s can contain is 2. We have 2p, the highest that p can contain is 6. This makes 10. Then we need 5 more. The next one will be 2s, 3s rather. The highest it can contain is 2. This makes 12. So out of 15, we need 3 more. And next one will be 3p. So since this already makes 12, we need 3 more to make it to be what? To be 15. So that shows the electronic configuration of what? Of phosphorus. So let's look at one last one, which is magnesium. If you check, magnesium has the atomic number to be 12. So let's go with that. So we have it to be 1s2, 2s2, 2p6, and 3s2. So this is the electronic configuration of what? Of magnesium. So this is how you deal with the what? The electronic configuration of each of the what? Of the elements. Now with this electronic configuration, we can determine the group and the period of each of these elements. This one now, it falls. It can shows the period and the what? And the group in which they belong to. Now if you check this one belongs to period 3, because the last number here is 3. And group what? Group 7. If you have any, if you have your electronic configuration like this, and you have the last orbit yet to be completed rather, then you have to add it up. That will be 5 here plus the 2 here, which making it to be what? To be 7. Though if it's complete, then you don't have to add again, like this one now. Or better still, just make sure that you add them together. Now if you see, for the sodium here, you have the sodium, it is period of 1, and period 3 rather, which is this, and it belongs to group 1. Sodium belongs to group 1, and it belongs to what? Period 3. Or better still, just check the last sub-orbits that we have. Like this one, you should know that these are the 3 that contain 1s. These are the 2 that contains 3 as a subscript. So this is the only one that contains what? 3 here. And this one here, this is the only one that these are the two that contain 3 as last one, and this is the only one that contain 3 as well. So if you check this one we have the period to be 3. That's the 3 here, the last one. The last one, what's the subscript? That's 3. This one also have the period to be 3. This one also have the period to be 3. Last number. This one we also have the period to be 3. And this one we have the group to be 7. That's 5 plus 2, that's 7. This one we have the group to be 1. That's the only subscript here, because we only have 1 3 here. This one we have the group to be, that'll be 3 plus 2, that's 5. This one we have the group to be, we just have only one s, only one 3s here. So the group will just be what? Will be 2. Now if you check this on the periodic table, so if you check this, we said the chlorine is in group 7, is in period 3, group 7. Period 3, group 7, that's chlorine. If you check this is chlorine, and this is the first period, second period, third period. So it's in period 3 and group 7. 1, 2, 3, 4, 5, 6, 7. It's in period 7. Let's check the next one. Next one is sodium. Sodium is in period 3, group 1. So period 3, group 1, we have it to be 1, 2, 3. That's period 3 and group 1, just the first group. Now, the next one is phosphorus. Phosphorus is group 3, period 5. Group 3, period 5. We have this to be group 3. Phosphorus is here. So that's 1, 2, 3, period 3. And group 5, that's 1, 2, 3, 4, 5. And the last one. So let me talk about, all of these belong to period 3. So let me talk about another one that belongs to another period. Let's pick another one. Let's say oxygen now. Oxygen belongs to period 2. Let's look for the electronic configuration of oxygen. Oxygen has the atomic number to be what? To be 8. That's oxygen. The atomic number is 8. So let us deal with the electronic configuration of oxygen. So oxygen, let's say oxygen, that will be 1s2, 2s2, this one is 4, and 2p, what is that? That will be 2 plus 2, that's 4. It remains 4 to make this to be completed. And this is 2 plus 2, that's 4 plus 4, that's 8. So now, if you check this very well, oxygen, the last, you can see that this and this, they have the same thing, which is 2, 2. So that shows that oxygen belongs to period. The period, the coefficient of the last determine the period. So that's 2. But the group will now be, since these are the 2 that are the same like this, 2, 2. Consider this is the 3, 3. We only have 1 3 here, that's the common. You cannot take this 3 with this 2. They are not the same. So now if you check this, the 2, 2 we have, they are 2. So let's add them up to that. That will be 4 plus 2, that's 6. So the group is what? Is 6. So now if you check, the group is 6 and the period is what? The period is 2 and the group is 6. So let us see. There is oxygen. That will be 1, 2. That's the period 2. And the group will be 1, 2, 3, 4, 5, 6. That's group 6. This is how to know the period and the group of each element on the periodic table. Now using the sp3 hybridization. Though we can use the KLM to represent this as well, to know the group and the period. If you use KLM, don't forget that for the K has the highest number to be 2, L has the highest number to be 8, M has the highest number to be 8 as well, and the N has the highest number to be 18. Yes, I've talked about this under another episode, so you have to go and watch that. Now, that is, I've talked about the quantum number, because this is divine according to principal quantum number, and SPDF is divine according to azimuthal quantum number. Now, if I want to use this process to know the group and the period of the chlorine here, I'll now bring it, I'm going to 17. So that will be 2, the highest that this one can contain, 8. And don't forget that 2 plus 8 is 10. So this one will now, that means I have 7 left. That will be 2 plus 8 plus 7, that's 17. If you check this, the last number here represents the word, the group. That means this belongs to group 7, and the period is 1, 2, 3. So that's what? Period 3, but what? Group 7. Let's talk about the next one. The second one is sodium. Using KLM, that will be 2, 8, 1. 2 plus 8 is 10 plus 1, that's what? 11. If you check this, this is, the last number represents the what? The group. That's group 1. And the period is 1, 2, 3. That's period 3. Next one is 12. That will be 2, 8, 2. So the last number, which is group 2, we have 15 rather. That's 15. So before we go to magnesium, 15. So 15, let's go to 15. That'll be 285. 285. So the last number is for the group. That's group 5. And the period is 1, 2, 3. That's 3 as well. That's why we have this. And next one is magnesium. That's 282. So the last number represents the group. That's 2. And the period is also 1, 2, 3. And let's talk about the last one here. That's oxygen. That's 2, 8. Okay, oxygen is 8. That'll be 2, 6. That'll be 2 plus 6. That's 8. So you now see the last number is 6. That means it belongs to what? Group 6. And the period is 1, 2. That's just period 2. That's how to detect the group and the period using KLM principle, and at the same time using SPDF principle. Now let us proceed to the properties of periodic table. Now let me talk about some properties. The first one I'll talk about, let me talk about the properties, and at the same time let me talk about the properties down the group, and at the same time across the period. Now across the period I'm talking about is from left of the period to what? To the right. From left to the right. That is what I'm talking about. From left to the right. From left to the right. What am I talking about? Now see, if you see this periodic table here that I showed you the other time, now, sorry, if you see this one, now, the first 20 elements here, I have this to be across the period like this. This is the period, and this is down the group. So the down the group is from the top to the down, and across the period I'm talking about is from the left to the what? To the right. So you have to get this done, because examiner can ask you across the period from right to left. So you just have to inverse it. So now, if you know from left to right, you are good to go. Now the first property I will be talking about is atomic size. Now the atomic size of the periodic table, it's for down the group, it increases down the group. It increases down the group, because if you see very well, as for the periodic table, the number of shell that hydrogen has is just 1. Number of shell that this one has is 2. This one is 3. So as it goes down the group, the number of shell words increases, but across the period it's what? It decreases. It decreases across the period from left to right. From left to right it decreases because of what? Because if you see this, the beryllium has the number of electrons to be 1, 2, 3, 4. So it is 4. If you see this one, the first orbit will be 2, and the second one will also be what? Be 2. So making it to be what? To be 4. If you compare this with oxygen here, oxygen is 2 first, because oxygen is 8. So it will have 6 at the outermost shell. So 6. Now as you can see, that this one, every of these electrons are drawn to the center of this circle. Now you notice that the shape of this one will be somehow bigger than the shape of this one, because each of these electrons will definitely draw the side of this shape to the wall, to the center. So you can see that the force that will draw this to the center is bigger, or is more than the force of this one, because outside of this one is just only one, it's just only 2 electrons, but this one, in the second shell of this one, we have 6. So they will draw it more than the what? Than the outside the second shell of this one, which is just 2. So that's why across the period from left to right it decreases, but from down the group it's what? It increases. Number 2. Now the next one is atomic radii. The same thing with atomic radii. Atomic radii also increases down the group and decreases across the period. Number 3, we have the ionization energy. Ionization energy, because of my time, let me just give you the short, and I will be explaining in the other aspect. It decreases down the group and it increases across the period. Number 4, we have the electron affinity. Electron affinity, it decreases down the group and it increases across the period. Next one, number 5, we have the electronegativity. Electronegativity, the same thing with electron affinity. It decreases than the group and it increases across the period. Number 6. Number 6, we have the metallic character. Metallic character, it increases, it's opposite of this one, it increases than the group and it decreases across the period. Number 7, we have electropositivity. Electropositivity is the same thing as metallic character, so it increases than the group and it decreases across the period. Now these are the 3. Now like, comment and subscribe. These are the 7 properties I'm going to share. In the next episode, we'll be talking about each group on the periodic table. So like, comment and subscribe. I am Ishola David, blessing by name, popularly known as General David. At the comment section, tell me the electronic configuration of nitrogen. Nitrogen is 7, so let me know the electronic configuration of nitrogen and the electronic configuration of calcium, which is 20. So type it at the comment section. Like, comment and subscribe for more videos. I am Ishola David, blessed by name. Thank you.